Hello and welcome to the next section of videos in the Rust Recipes series. During this section of videos, we are going to be looking at futures and how we can handle async I/O. So the question is, what are futures? And futures are basically a cheap way to do threading in a context where you don't have as many threads. But the way they work is really quite different to that. With threads, you ask the operating system for another thread, and the operating system starts that thread and runs it as a completely separate process from the thread you've started on. So now you have two separate threads running, and each of them can access a lot of the same data when needed. A future, on the other hand, is basically an object with a function that will return if there is something it cannot do. For example, it's waiting on the file to load, and it's waiting on the file system to do that. Or it's waiting on a TCP connection, or something like that. If it can't do that, instead of being a separate thread and just waiting for its thing to come up and letting the OS handle that, it just says, well, actually, I can't do anything. When I can, let me know and I'll have another go. But this is hidden in a struct which some other operator has to call in order to keep asking to see if there is something else it needs to do. And actually, it's done in a clever way so that it doesn't just keep asking. It can be done where if it tries to do something and it needs to wait for something, it will wait till it's woken up. A little bit tricky to explain here. We will get through more of that in detail. It's a lot like a JavaScript promise. If you've used promises where you can make a function asynchronous and that will return a promise object, and a future is very similar to the promise object. Returns something which you can then call methods on, like once you're done with that, do this with the result, which is the function then, and other things like that, so you can keep everything passing on in an asynchronous way. Biggest difference between them is that in JavaScript, the thing that keeps pushing the promises to completion is embedded in the JavaScript language, whereas in Rust, this is in a library, and you have to tell it to start, and you have to tell it to keep running those processes. And you can write these libraries yourself. I want to also compare futures with green threads, or if you use GoFuncs. And green threads are, of course, basically a way of creating threads, but they're not really threads. They are program internal threads as opposed to operating system threads, which means you can start lots of them and store them cheaply. I mean, as cheaply as you can program that to happen. In Go, they've done, I'd say, a pretty good job of that, which are, again, built into the language. The Rust team really wanted to focus their efforts on the idea of zero-cost abstractions. If you don't use something, it shouldn't cost you anything to not include it. Now, with green threads, as are built into the Go language, for example, the language is so built around the concept of green threads or GoFuncs that actually, even if you're not going to write a multi-threaded program, it's still using the green threads in the runtime. Actually, Go runs pretty fast, so it's not that big a problem, but it is worth noting that there is a cost, and the Rust team really didn't want to have that cost for someone who didn't want to use it. And the other core part of zero-cost abstractions is that they shouldn't cost you more than if you hand-wrote and optimized the code yourself in terms of speed. In Rust, it's a bit more work to write than writing green threads, but once you get your head around the concept, and now that AsyncAwait is coming really soon into Rust, they are going to be a lot more usable and a lot faster. This is coming in the next couple of months. Thankfully, I can still demonstrate to you how it works because in the unstable Rust, this feature is enabled, so we can use it as it's coming. But unstable Rust is conceptually new features that may or may not be added to the stable Rust language. Because once something is stable in the Rust language, it cannot be changed. But while something is still in unstable Rust, they can make changes and improvements. And AsyncAwait is pretty much there. They're just waiting on a couple more tests and a couple more things being correct. And then async and await will be added to the language, and futures are going to change a little bit. Because of that, some of the code we're going to write in this won't be needed if you come to this maybe in 3 or 4 months' time. But most of the code will be basically as it needs to be for you to be able to use it.